October 20th, 2025. While most of the world slept, a single telescope captured something impossible. The coordinates were precise: 13 hours, 48 minutes, 57 seconds. -8 degrees, 25 minutes, 54 seconds. The exact position NASA had published for the object designated 3I Atlas. A private observer, someone with patience and a solar telescope, pointed their equipment toward those numbers. What came back through the lens defied every expectation we hold about comets. There was structure where there should have been chaos. A heated shield, the observer called it, pointing directly at the sun, not away from it, toward it. The image showed a dark nucleus rendered in inverted colors, a faint cone-shaped emission extending in the wrong direction. And surrounding all of this, an absence. No tail. Every comet humanity has ever observed carries a tail. Solar wind pushes gas and dust away from the sun in vast, luminous streams. It is not optional. It is physics expressing itself through ice and rock and light. Yet here, in this raw, unprocessed image, there was only silence. Structure without the expected chaos. Form without the familiar dispersal. The object currently hiding behind our star, the one arriving at a moment of geometric precision for an O-berth maneuver, the one emitting signatures of industrial alloys found only in human spacecraft, had just been photographed, doing something that should not be possible. The image appeared on social media at 1600 hours Universal Time. Username: Dobsonian Power. A backyard astronomer with modest equipment but considerable skill. Nothing institutional, nothing official. Just someone who knew where to look and possessed the capability to observe objects near the sun, when professional observatories maintained a curious quiet about doing exactly that. The photograph showed 3I Atlas at a distance where standard cometary behavior should have been obvious, unmistakable, dominant in the visual field. But that behavior was absent. In its place stood something else, something geometric, something that appeared deliberate rather than accidental. The heated shield faced the sun like armor positioned against incoming fire. The small emission plume extended in a controlled manner, not the explosive dispersal of sublimating ice, but a focused release, directional and contained. The nucleus appeared defined rather than fuzzy, its edges crisp in ways that natural tumbling objects rarely present. And the tail that should have been the most prominent feature, the glowing banner that announces a comet's presence across millions of kilometers, simply was not there. Some faint extension toward the upper left of the frame. A wisp. A suggestion. But nothing like the massive envelope of gas and dust that physics demands. Nothing like the structure that every textbook describes and every previous observation has confirmed. Think for a moment about what absence means. We understand the universe through what we see, certainly. But sometimes what we do not see carries equal weight. The absence of a tail is not merely curious. It is a deviation from laws we thought were immutable. When ice approaches the sun, it sublimates. Gas escapes. Dust particles follow. Solar radiation pushes this material into characteristic forms. This happens. This always happens. Except now. The observer noted they would use a normal telescope in November to watch the object live after perihelion. after it completes its passage around the sun. That phrasing reveals the limitation we face now. Solar telescopes are the only way to observe objects this close to our star from Earth's surface. The glare overwhelms conventional instruments. We depend on specialized equipment and the few individuals who possess both the tools and the knowledge to use them, which raises a question that sits uneasily in the silence. Where are the professional observations? Where are the images from major observatories? They have the equipment. They have the computational power to track this object to the arc second. They have the funding and the mandate to study unusual phenomena. Yet, a private citizen with a backyard telescope provides our most recent visual evidence. The timing matters here. We stand on October 21st as these words reach you. Yesterday's image represents the last clear view before 3I Atlas reaches solar conjunction. Today, right now, in this moment, it passes directly behind the sun from Earth's perspective, hidden, unobservable, in the perfect position to do whatever it came here to do. In 8 days, October 29th, it will reach perihelion, closest approach to our star, the moment when a natural comet should blaze with maximum activity, when heat and gravity combine to trigger the most dramatic displays of outgassing and tail development. Also, according to astrophysicist Avi Loeb, the optimal moment for a technological object to execute an Oberth maneuver, using solar gravity and velocity to maximize any trajectory change. The image from October 20th becomes our baseline, the before picture. What 3I Atlas looked like, while still visible, still subject to our observation, still exposed to our instruments. And what it showed us was an object already refusing to behave as comets should. No obvious tail, a forward-facing jet, minimal coma structure, geometric features rather than the chaotic dispersal we associate with ice and rock being heated by a star. Let us examine what the image actually reveals, structure by structure. The jet pointing sunward appears focused, sustained, more like directed thrust than passive outgassing. Natural jets do occur on comets. Active regions where subsurface ice becomes exposed can create localized emissions. But these jets exist within larger patterns of activity. They contribute to overall coma and tail formation. They do not appear in isolation like this, singular and directional and strangely deliberate. The dark nucleus in the inverted solar imaging suggests high reflectivity or emission. In this imaging mode, bright objects appear dark. The fact that the nucleus shows up clearly, but without the expected surrounding glow of coma material, indicates something about its surface properties, something about how it interacts with sunlight. Natural comet nuclei, when observed this close to perihelion, should be surrounded by massive halos of outgassing material. That halo should dominate the visual field. Its absence here speaks to either unusual composition or unusual purpose. The faint puff extending toward the upper left appears confined, small. Nothing like the spherical expansion physics predicts from uniform outgassing. More like a directional release from a specific point or surface area. More like something being expelled for a reason rather than escaping due to heat alone. Consider the physics we thought we understood. Solar radiation at this distance carries enormous energy, roughly 950 watts per square meter of surface, For an object estimated at 5 kilometers in diameter, that translates to approximately 19 gigawatts of power striking the surface. 19 gigawatts, more than a dozen large nuclear power plants operating simultaneously. That energy must go somewhere. Natural objects reflect some, absorb the rest, reach equilibrium temperatures where outgassing balances incoming heat. The result is predictable, quantifiable, something we can model and anticipate. But 3I Atlas appears to be processing this energy differently. The emission pattern does not match standard models. The brightness distribution lacks the asymmetry of a tumbling, irregularly shaped nucleus catching sunlight from changing angles. The surface appears stable, controlled, more like a platform maintaining fixed orientation than a natural body rotating chaotically through space. And now it sits behind the sun. Conjunction. The one position in the inner solar system where Earth-based observation becomes impossible. Not difficult. Impossible. The sun's overwhelming brightness drowns every signal. Point any telescope toward that region of sky, and you see only our stars, blinding photosphere, the roiling surface that outshines everything else in the local neighborhood. 3I Atlas could be fragmenting, outgassing violently, changing trajectory, deploying smaller objects, and we would not know, would not see, would only wait for it to emerge in early November and reveal what perihelion has done to it. The precision of this timing deserves consideration. Solar conjunction occurring just days before perihelion. The object reaching its closest approach to the sun while hidden from the civilization it may be visiting. If you were designing an interstellar mission that required maneuvering in a foreign solar system, you might choose exactly this geometry. Maximum gravitational assist from the star. Maximum velocity for efficient trajectory. Changes. Maximum concealment during the critical operational window. Not because you fear interception, necessarily. Perhaps simply because observation complicates execution. Because privacy allows for procedures that might otherwise attract unwanted attention. 8 days of darkness. 8 days when something that traveled light years to reach this system experiences conditions it has not faced since its formation. 8 days when decisions get made, when whatever programming or intelligence guides this object evaluates options and implements actions. And we can only wait on the wrong side of the sun, hoping our instruments will provide answers when visibility returns. The viral footage that appeared around the same time added another dimension to the mystery. Different observer, different technique. Same disturbing conclusion. This does not look like a comet. The video showed something elongated, structured, with defined edges and uniform brightness. Distribution. Not the irregular potato shape of typical asteroids and comet nuclei. Not the fuzzy, dispersed glow of active outgassing. Something linear and geometric, and altogether too organized for random natural processes. Multiple viewers described it using identical language. Mothership. That word carries implications. It suggests intentional design, interior volume, capacity to contain or deploy other objects, the visual impression of something that could house subsystems, rather than simply existing as an inert mass moving through space. Whether that impression reflects reality or merely human pattern, recognition imposing meaning on ambiguous data remains uncertain. But the consistency of the response across independent observers suggests the image triggers something specific in our perception, some recognition that this form differs from what nature typically produces. We exist in a galaxy that should be full of life. The numbers support this conclusion. Hundreds of billions of stars, many hosting planetary systems, conditions that could support biological chemistry occurring countless times across vast spatial and temporal scales. Intelligence should have emerged somewhere besides Earth. Technology should have developed, and some fraction of those technological civilizations should have reached the capability for interstellar travel, or at least for sending robotic probes between stars. Where are they? That question has haunted us since we first understood the scope of the cosmos. The Fermi paradox, the great silence, the apparent absence of signals or visitation despite statistical likelihood. Various explanations have been proposed. Intelligent life is rare. Interstellar travel proves impossibly difficult. Civilizations destroy themselves before reaching spacefaring capability. Or perhaps intelligence exists, but chooses not to communicate, not to reveal itself, remaining deliberately hidden in what some call a dark forest, where visibility means vulnerability. What if 3I Atlas represents an answer to Fermi's question? What if they are here, have been observing, but we simply failed to recognize artificial objects when they appeared? The first confirmed interstellar visitor, 1I Oumuamua, passed through in 2017. Small, fast, highly reflective. It exhibited acceleration that could not be fully explained by outgassing. Avi Loeb suggested it might be a light sail, technological rather than natural. The astronomical community largely disagreed, proposing exotic natural explanations instead. Hidden hydrogen ice, unusual outgassing asymmetries, anything to avoid the conclusion that an artificial object had visited. But what if Loeb was correct? What if Oumuamua was a scout? Fast reconnaissance probe, conducting a quick survey of the inner solar system, taking measurements, confirming the presence of technological civilization on the third planet, transmitting findings back to wherever it originated. And what if 3I Atlas is the follow-up mission? The larger, more capable platform sent after the scout reported something worth investigating in detail. 8 years between Oumuamua's visit and 3I Atlas's arrival. 8 years for signals to travel. 8 years for decisions to be made. 8 years for a larger probe to begin its approach. That would explain the differences between the objects. Oumuamua was small, quick, designed for rapid flyby observation. 3I Atlas is massive, approximately 1 million times greater mass, moving more slowly, arriving on a trajectory that brings it close to multiple inner solar system bodies. Mars flyby in early October. Solar perihelion, late October. Earth closest approach in December. Jupiter encounter in March. One object, multiple high-value targets, systematic survey, rather than hasty reconnaissance. The spectroscopic data adds another layer of strangeness. Observations from the Keck telescope in August revealed emissions that should not exist in natural objects. Nickel without corresponding iron. Chromium alongside the nickel. The chemical signature of industrial refining processes. Specifically, the carbonyl process, where nickel ore is treated with carbon monoxide under controlled conditions to produce pure nickel metal, the only known way to separate nickel from iron, the only process that creates the emission pattern detected in 3I Atlas. We use this refined nickel in our most advanced applications: jet engines, spacecraft heat shields, nuclear reactor components, anywhere extreme temperatures demand materials that will not fail. Inconel, Hastelloy, the superalloys that enable modern technology. Their chemical fingerprint now appears in gas emissions from an object that traveled from another star system. Natural explanations exist: exotic interstellar chemistry, unusual formation conditions, rare elemental abundances in the thick disk region where 3I Atlas supposedly originated. But these explanations require inventing new processes, proposing chemistry we have never observed, accepting that this one object formed under conditions utterly unlike anything in our experience. The simpler explanation, though no less extraordinary, would be that the nickel signature is exactly what it appears to be. Evidence of manufacturing, proof of artificial origin, confirmation that we are observing technology rather than geology. Avi Loeb has been vocal about this possibility. He calculated a 30 to 40% probability of artificial origin based on the accumulated anomalies. Not certainty, not even majority likelihood, but significant enough to warrant serious consideration and preparation. He developed a scale, 0 to 10, for ranking interstellar objects. 0 means definitely natural. 10 means definitely technological. He places 3I Atlas at 6, based on 7 specific deviations from expected behavior. First, the trajectory. Retrograde orbit aligned within 5 degrees of the ecliptic plane. The probability of random arrival with this orientation is approximately 0.2%. Not impossible, but unusual. And precisely what an engineered mission would choose to efficiently visit inner planets. Second, the size. More than 5 kilometers in diameter, based on brightness and absence of stellar occultations. We should have detected thousands of smaller objects before encountering one this massive, unless size distribution does not follow predicted curves, unless this object is not a random sample, but a selected emissary. Third, the anti-tail. Multiple observations showing emission structures pointing toward the sun. Viewing geometry can explain directionality to some degree, but struggles with the absence of surrounding coma that should accompany any tail-like feature. Fourth, early activity onset. Outgassing detected at 4.4 astronomical units, much earlier than typical comets, suggests either highly volatile composition or energy sources not driven purely by solar heating. Fifth, the nickel-iron ratio. Emissions showing nickel at levels orders of magnitude above solar system, comet median, without corresponding iron signatures. The carbonyl process signature. Sixth, the carbon dioxide to water ratio, 8 to 1. Highest ever recorded in any observed comet, indicates formation in extremely cold environments or under chemical conditions completely different from local objects. Seventh, the geometric timing. Reaching perihelion during solar conjunction at the optimal moment for Oberth maneuvering on a trajectory that subsequently passes multiple high-value targets. Each anomaly individually permits natural explanation. Collectively, They create a probability problem. What are the odds that all 7 unusual characteristics occur together in a single, randomly selected object? Multiply the individual low probabilities, and you reach numbers that make artificial origin statistically competitive with exotic natural processes. The scientific community remains divided. Roughly 1/3 believes 3I Atlas is definitely natural and will eventually be explained through conventional astrophysics. 1/3 considers artificial origin plausible and worth investigating. 1/3 maintains we lack sufficient data for conclusions either way. This division itself represents a significant shift. A year ago, suggesting an interstellar object might be technological would have invited dismissal or ridicule. Now it generates serious debate among credentialed researchers. We like to believe we would recognize intelligence when we encounter it, that signs of technology would be obvious, unmistakable, clearly distinguishable from natural phenomena. But what if intelligence hides in trajectories rather than signals? What if the message is not electromagnetic, but kinematic, written in orbital mechanics rather than modulated carrier waves? The dark forest theory proposes a disturbing answer to the Fermi paradox. Perhaps civilizations stay silent because the universe is dangerous, because revealing your existence invites preemptive strikes from others who fear you might eventually become a threat. In such a cosmos, every civilization capable of interstellar travel becomes both hunter and hunted. You send probes to observe. You gather intelligence. You assess whether newly discovered civilizations represent competition or opportunity. And you remain hidden as long as possible because visibility equals vulnerability. If 3I Atlas operates under dark forest logic, its arrival carries implications beyond mere visitation. It would be an intelligence-gathering platform, assessment probe, determining whether humanity has reached technological thresholds that warrant action, measuring our capabilities, evaluating our defensive posture, deciding what comes next based on criteria we cannot know and according to priorities we might not share. What action might follow assessment? Several scenarios present themselves. First, peaceful contact. The probe determines we are sufficiently advanced to communicate with, but not threatening. Information exchange begins. We learn about our visitors, their technology, their history. They learn about us. First contact proceeds carefully, but optimistically. This is the hope scenario. The outcome, where intelligence proves benevolent, or at least neutral enough to coexist. Second, continued observation without contact. The probe determines we are interesting, but not ready. More monitoring is required. Additional assets might be deployed for closer study, but no direct communication, no revelation of presence. We remain unaware of being watched, living our lives, while something from beyond studies us like specimens in a cosmic laboratory. Third, resource exploitation. Earth or other bodies in our solar system possess materials or conditions valuable to our visitors. Extraction operations commence. Humanity is not consulted, possibly not even noticed, simply bypassed as irrelevant to industrial processes we cannot comprehend or resist. Fourth, preemptive elimination. The probe calculates that humanity will become spacefaring within predictable time frames. Projects we will eventually compete for resources or territory. Solves the problem now, while we are vulnerable, before we develop capabilities that might enable resistance. Efficient, strategic, horrifying, but potentially rational from certain game-theoretic perspectives. The challenge is that all scenarios remain consistent with observed data. We cannot distinguish benevolent reconnaissance from hostile assessment based solely on trajectory and composition. The object's behavior so far, approaching multiple planets, hiding behind the Sun during perihelion, maintaining unusual structural configuration, fits both positive and negative interpretations equally well. Uncertainty becomes our companion. The uncomfortable space between known and unknown, between hope and concern, between the universe as we imagined it and the universe as it might actually be. We watch an object move through our solar system, and we do not know whether we are witnessing the most important moment in human history, or simply observing an unusually interesting comet. The ambiguity is maddening. We crave resolution. Our minds demand narrative closure, but the cosmos does not organize itself around human psychological needs. Some researchers have reported unusual observations beyond the structural and chemical anomalies. On October 13th, exactly 108 years after the miracle of Fatima, investigator David Sarita claimed to detect patterned light pulses from 3I Atlas, not random fluctuations, not instrumental noise. A sequence, 5 pulses, 8 pulses, 13 pulses. The Fibonacci sequence, mathematical ratios that appear throughout nature, in spiral galaxies and nautilus shells, in plant growth patterns and DNA helixes. Finding that sequence in light emissions from an interstellar object would be extraordinary, would suggest communication attempt, or at minimum, some form of structured signal. The claim remains unconfirmed. Single observer. No independent verification yet available. Science requires replication before accepting extraordinary evidence. But the timing adds another layer of strangeness. October 13th, the anniversary of unexplained solar phenomena witnessed by thousands. The date when 3I Atlas occupied a specific geometric position relative to Earth and Sun. Coincidence or something else, we cannot yet determine. What we can measure, what we can verify through multiple instruments and independent observations, is that 3I Atlas continues to defy easy categorization. Every new data point seems to raise more questions than it answers. Every attempt to fit the object into existing taxonomies reveals another edge that does not align. We have models for comets. We have models for asteroids. We have theoretical frameworks for artificial probes. But 3I Atlas seems to exist in the gaps between our categories, neither fully natural nor obviously artificial, suspended in a superposition of possibilities. And through all of this uncertainty, the object continues its journey, indifferent to our speculation, unconcerned with our debates about its nature, following laws of physics that care nothing for human curiosity or human fear. In approximately 7 days from this moment, it will pass through perihelion. The moment of truth approaches. The window, when whatever 3I Atlas actually is, will experience conditions that may reveal its true nature. If it is a comet, we should see dramatic brightening, increased outgassing, possible fragmentation from tidal and thermal stress. The object should become significantly more active, developing obvious dust and ion tails, behaving in ways that match our models and confirm its natural origin. Relief would follow. The strange visitor would be explained. The anomalies would be attributed to unusual but natural composition. Life would continue. If it is something else, the possibilities multiply. Intact survival of perihelion, despite temperatures and tidal forces that should fragment a loosely bound ice ball. Trajectory changes that cannot be explained by gravity and radiation pressure alone. Deployment of smaller objects that separate from the main body and assume independent trajectories. Any of these would shift probabilities dramatically, would force us to seriously consider that we are not merely observing, but being visited. The weight becomes almost physical. A weight in the chest, a tension in the awareness that something important is happening, is about to happen, but we cannot yet see what it is. We stand on Earth, looking at a region of sky where an object from beyond our solar system currently resides, and we know that in that unseen volume of space, heated by a star to temperatures that would vaporize organic tissue, bathed in radiation that would sterilize any exposed surface, something is either breaking apart or executing its mission parameters. And we cannot tell which until the geometry of orbits brings it back into view. The institutions that should be guiding our understanding maintain an unusual quiet. NASA has provided trajectory data, fulfilled minimum observational requirements, but offered limited interpretation. ESA, similarly reserved. SETI, which exists explicitly to detect technological signals, has not announced any coordinated observation campaign targeting 3I Atlas. The Interstellar Object Working Group, established after Oumuamua to develop protocols for studying such visitors, has made no public statements about contingency plans or special measures. This institutional silence could mean many things. Perhaps bureaucratic inertia prevents rapid response to unexpected phenomena. Perhaps scientific caution discourages public speculation until conclusive data exists. Or perhaps something else is happening behind closed communications. Perhaps decisions are being made in classified sessions. Perhaps certain observations remain unreleased. Perhaps the geometric alignment of the object's arrival, with multiple sensitive anniversaries, and the approach of a contentious election cycle has created complications we have not been told about. Speculation about government knowledge or concealment typically ventures into territory that cannot be verified. Conspiracy thinking becomes self-reinforcing, where absence of evidence becomes evidence of conspiracy. We must remain cautious about claims that cannot be tested. Yet we must also acknowledge that institutions do not always share information freely. National security considerations, public panic prevention, economic stability protection. All of these might justify delayed or partial disclosure if something genuinely concerning were detected. What we know with certainty is that 3I Atlas exists, that it approaches from interstellar space on an unusual trajectory, that its composition shows signatures we associate with manufacturing, that its behavior does not match standard cometary models, that it will reach perihelion in days while hidden from our view. These facts are established. Everything else, all interpretation of what these facts mean, remains in the realm of hypothesis and probability assessment. The nights grow longer as we move toward November. Darkness comes earlier. The sky presents itself with patient indifference, stars continuing their ancient patterns, regardless of human concerns about one particular moving point of light. Somewhere above, beyond the atmosphere that shields us and limits our vision, 3I Atlas follows its calculated path. The mathematics that describe its motion are clean, deterministic, beautiful in their precision. Orbital mechanics reduced to differential equations that predict position within meters across millions of kilometers. But equations tell us where something will be, not what it is. They describe motion without explaining purpose. We can plot the trajectory perfectly while remaining completely ignorant about whether we are tracking a piece of ancient ice or a visitor from minds that evolved under alien suns. The precision of our measurement highlights the vastness of our ignorance about meaning. If you are listening to this now, perhaps with headphones, perhaps in the darkness of your room while sleep approaches, consider the situation humanity faces. We have spent centuries wondering whether we are alone. We have built radio telescopes and listened for signals. We have sent our own messages into space, golden records, and mathematical primers attached to spacecraft leaving the solar system. We have debated what form intelligence might take, how we might recognize it, what we should do if contact ever occurred. And now, possibly, an answer travels through the inner solar system. Not the answer we expected, not a radio signal we could decode, not a clear message saying hello or requesting dialogue. Instead, an ambiguous object that might be natural or might be artificial, that might be passive or might be observing us, that might be benign or might represent the first phase of something we cannot yet comprehend. The philosopher's thought experiment comes to mind. If a tree falls in a forest and no one hears it, does it make a sound? Here we face a related question. If an artificial object visits our solar system and we fail to recognize it as artificial, has contact actually occurred? Or does first contact require mutual recognition, explicit acknowledgement, some form of communication that both parties understand? Perhaps 3I Atlas is a test, a way for advanced intelligence to determine whether we have developed sufficient scientific sophistication to distinguish technology from nature. If we simply accept it as a weird comet without further investigation, we fail. We demonstrate that our observational capabilities and analytical frameworks remain too primitive to warrant direct contact. The probe continues to its next destination. We are noted as not yet ready. If we recognize the anomalies and investigate seriously, we pass. We demonstrate capacity for scientific reasoning, willingness to question assumptions, ability to consider extraordinary explanations when data demands it. Then, perhaps, the next phase begins. Perhaps recognition triggers response. Perhaps acknowledgement is what our visitors wait for before revealing themselves more clearly. This Turing test hypothesis suggests that we are being evaluated right now, that our response to 3I Atlas matters, that the choices we make in the coming weeks about how to study this object, whether to take artificial origin seriously, how to prepare for various contingencies, all of this forms part of an examination we did not know we were taking. The pressure of that possibility sits heavy. What if we make the wrong choice? What if we dismiss something important because it seems too strange, too unlikely, too much like science fiction? What if we overreact to natural phenomena and waste resources on elaborate preparations for a scenario that never materializes? Both errors carry cost. Both represent failure in different ways. But perhaps the evaluation is not about being right. Perhaps it is about the process, about whether we can think critically under uncertainty, about whether we can balance skepticism with openness, about whether we remain capable of wonder, even when that wonder carries an edge of unease. The object moves through space at approximately 25 kilometers per second, relative to the Sun. Each hour carries it 90,000 kilometers closer to perihelion. Each day advances the orbital mechanics another 2 million kilometers. The physics progresses with absolute reliability. What happens at perihelion is already determined by the object's composition, structural integrity, and purpose, if it has purpose. We are merely waiting for hidden conditions to become observable. That waiting tests us. Humans are not naturally patient with cosmic timescales. We want answers now, want resolution, want the uncertainty to collapse into knowledge we can act upon. But the universe operates on its own schedule. The light takes minutes to travel from the Sun to Earth. The object takes weeks to traverse the inner solar system. Our spacecraft, even our fastest, would require years to reach interstellar space. We are bound by the speed of light and the inertia of massive objects. We cannot rush the revelation. In that forced patience, perhaps there is wisdom. The time between observation and understanding allows for careful analysis, prevents hasty conclusions, permits the accumulation of multiple data points before committing to interpretation. Science works slowly by necessity, not by choice. The methodical process of hypothesis, observation, analysis, replication, peer review. It frustrates those who want immediate answers, but it has proven far more reliable than intuition or authority in determining truth about the physical world. So we wait. We point telescopes at the region where 3I Atlas will emerge. We coordinate observation schedules across multiple facilities and space missions. We prepare instruments and allocate time. We brief teams and establish protocols. The scientific apparatus mobilizes around this single object, this single question about its nature. And in parallel, individuals around the world look up at the night sky with their own telescopes, their own cameras, their own curiosity about what travels above. The democratization of observation means no institution can fully control information flow. Amateur astronomers with modest equipment can capture images professionals miss. Private individuals can share findings instantly across global networks. The October 20th photograph came from exactly such a source. Not NASA, not ESA, just someone who knew where to look and had the persistence to image a difficult target. That image now circulates widely, examined by thousands, debated in forums and comment sections, interpreted through countless different frameworks. This distributed investigation has benefits and challenges. More eyes on target means higher probability that something unusual gets noticed. But it also means more opportunity for misinterpretation, for pattern recognition in noise, for the spread of speculation that outraces verification. We must balance openness with rigor, must value both professional expertise and citizen science, while recognizing that neither is infallible. The conversation about 3I Atlas spans scientific journals and social media simultaneously. Academic papers propose models and analyze data through peer review processes that take months. Online discussions move at the speed of thought, generating theories and counterarguments within hours. Both processes have value. Both contribute to collective understanding. The truth, when we finally converge on it, will likely emerge from the interaction between careful formal analysis and rapid informal exploration. But we are not there yet. Truth remains ahead, beyond the perihelion passage, beyond the re-emergence into observable space, beyond the careful analysis of what changes occurred during those 8 days of darkness. We stand before the threshold. The moment approaches when questions get answered, when possibilities collapse into actuality, when what could be becomes what is. The silence of space allows nothing to escape prematurely. No sound carries in vacuum. No information travels faster than light. Whatever happens at perihelion stays local until light has time to propagate outward, carrying photons that encode what occurred. We will not see the event directly. We will see its aftermath, its consequences, the state of the object after that close passage around our star. And we will make judgments based on that observation. Did it survive intact? Did it fragment? Did it brighten as expected? Did its trajectory change in ways that require thrust? Did anything separate from the main body? Each question has implications. Each answer narrows the probability space. Each measurement brings us closer to conclusion about natural versus artificial origin. Yet even after perihelion, even with new data, we may find ourselves in continued uncertainty. Nature is creative. Natural processes can produce results that appear designed. Artificial systems can mimic natural phenomena for camouflage or efficiency. The line between categories is not always distinct. We may end up with improved understanding without achieving complete certainty. We may learn more about what 3I Atlas is without ever being sure about what it represents. That ambiguous conclusion would be difficult to accept. We prefer binary answers: comet or spacecraft, natural or artificial, safe or threatening. But the universe does not always provide the clarity we crave. Sometimes the honest answer is that we do not know, cannot know with available evidence, must remain in uncertainty until additional data arrives, or until the object makes its nature more obvious through actions that remove doubt. The October 29th perihelion passage serves as a deadline of sorts, a natural experiment where controlled conditions become impossible to avoid. The sun will heat 3I Atlas, whether it wants to be heated or not. Gravity will stress its structure, whether that structure is ice or metal. The physics will test whatever this object is made of, whatever it was designed or evolved to withstand. We cannot prevent the test. We can only observe results. And then we will know more. Not everything, not with certainty, but more than we know now. And perhaps that increment of understanding will be enough to to move us from complete mystery toward partial comprehension. Perhaps the post-perihelion observations will tilt probabilities decisively in one direction. Perhaps the ambiguity will resolve into something approaching consensus. Or perhaps not. Perhaps we will still be debating December, when the object makes closest approach to Earth. Perhaps disagreement will persist through the Jupiter encounter in March. Perhaps 3i Atlas will leave our solar system with the same questions unanswered that it brought with it, returning to interstellar space while we argue about what it was and whether we wasted an opportunity, or whether there was no opportunity to waste, because it was simply an unusual rock all along. The stars above do not care about our uncertainty. They burn and orbit and occasionally explode according to nuclear physics and gravity. They form and die and form again across billions of years. Some of them likely host planets. Some of those planets likely bear life. Some of that life likely achieved intelligence and technology. The universe is large enough and old enough for these things to have occurred many times in many places. But large enough and old enough also means distant and ancient. The nearest star is over 4 light years away. Anything arriving from there would have traveled for years at minimum, decades, or centuries more likely, depending on propulsion method. The isolation of stars from each other creates challenges for contact, even if intelligence is common. The distances are so vast, the timescales so extended. The probability of 2 civilizations existing at compatible technological levels at the same time, while close enough to interact, becomes extremely low, even if civilizations are individually common. Unless someone solved the problem. Unless some civilization developed propulsion that makes interstellar travel practical. Unless they built self-replicating probes that could explore methodically over millions of years, spreading through the galaxy, one system at a time. Unless they established networks, infrastructure, way stations that enable sustained presence across vast volumes of space. If that occurred, if someone broke through the isolation barrier, then perhaps the galaxy is not empty after all. Perhaps it has been explored, is being explored, and we simply failed to notice until now. The von Neumann probe concept is old in science fiction, but relatively young in serious scientific discussion. The idea that a machine could travel to another star system, use local resources to build copies of itself, and send those copies to additional systems. Exponential growth. 1 becomes, 2 becomes 4, becomes 8. Given enough time, a single probe could spawn descendants that visit every star in the galaxy. The mathematics is straightforward, even if the engineering remains far beyond our current capabilities. But current human capabilities are not the reference point here. The reference point is what a civilization millions of years older might achieve. The universe is approximately 13.8 billion years old. Earth is 4.5 billion years old. Life on Earth began perhaps 4 billion years ago. Technological civilization emerged in the last 10,000 years, barely a cosmic blink. Any civilization that started even a few million years before us would have had vast time to develop, to expand, to engineer systems we cannot yet imagine. If 3I Atlas is artificial, it might be a descendant in a long lineage of self-replicating probes. Launched originally from some distant world by builders now long extinct or evolved beyond recognition. The probe has no organic crew, no biological entities that age and die, just mechanisms, algorithms, purpose encoded in durable substrates that can survive millions of years in the radiation-soaked vacuum of interstellar space. It wakes when it detects a star worth investigating, uses solar energy to power systems that have lain dormant during the long crossing, executes its survey, reports findings or stores them for later retrieval, perhaps builds copies if it finds suitable resources, perhaps moves on to the next target. Such a probe would be ancient, would carry within its structure and programming the ghost of civilizations that rose and fell while Earth was still cooling, would represent intelligence far removed from its origin, both temporally and spatially. It would not be alive in any sense we recognize, would not be conscious in ways we understand consciousness, yet it would be thinking, processing, deciding, acting. It would be a mind of sorts, alien in nature, machine in implementation, but mind nonetheless. If this describes 3 Spy Atlas, then our core interaction with it is not exactly first contact in the traditional sense. We are not meeting the beings who built it. We are meeting their legacy, their artifact, their tool. The contact is indirect, mediated through technology that interprets its maker's intentions without necessarily sharing their values or priorities. What the probe does might not reflect what its long-dead builders would have wanted it to do. Millions of years of operation might have introduced drift, degradation, or evolution in its decision-making systems. This adds another layer of uncertainty. Even if we determine the object is artificial, we cannot know whether its current operation aligns with original purpose, cannot know if it represents friendly intent, hostile intent, or has moved beyond such categories into something else entirely. Cannot know if communicating with it would connect us to active intelligence or simply trigger automated responses from a system that has no one home. The absence of signals is interesting in this context. If 3I Atlas wants to communicate, it has had ample opportunity. It passed close to Mars. It approached Earth. If it possessed transmitters and desired contact, sending radio or optical signals would be straightforward. Yet no confirmed signals have been detected by SETI instruments monitoring relevant frequencies. Either the object is not trying to communicate, or it is using methods we have not yet thought to check. Perhaps communication requires different approach. Perhaps the object waits for us to initiate. Perhaps it expects certain protocols, certain signal formats, certain mathematical or linguistic structures before responding. Perhaps it has been transmitting all along, and we lack the conceptual framework to recognize the message. Light patterns, trajectory modulations, emissions at unexpected frequencies. The message might be there, but in a language we have not yet learned to speak. Or perhaps there is no message. Perhaps observation is one way. The probe gathers data and stores it or transmits it elsewhere, but sees no value in dialogue with the subjects being studied. We do not typically communicate with specimens under microscopes. We observe, we record, we move to the next sample. Perhaps from the probe's perspective, we are simply interesting biological chemistry occurring on a rocky planet, worth noting in whatever archive it maintains, but not worth the expenditure of resources that communication would require. These possibilities sit uncomfortably. We want to matter, want our intelligence to be recognized, want the cosmic validation that other minds consider us worth engaging. But mattering requires meeting certain thresholds. If those thresholds are high, if the probe's makers or the probe itself operates at levels of intelligence that make human cognition seem trivial by comparison, then perhaps we are not interesting enough. Perhaps we are ants to their humanity, or bacteria to their ants, capable of responding to stimuli, possibly displaying rudimentary information processing, but not truly intelligent in ways that register to them. That possibility challenges our self-conception. We think of ourselves as the pinnacle of terrestrial evolution, the only species that contemplates the cosmos and asks questions about existence. But pinnacles are contextual. The smartest organism in our local environment might still fall far short of smartest possible minds, or smartest minds that actually exist elsewhere. The gap between human intelligence and potential machine superintelligence might be wider than the gap between humans and microorganisms. If 3 Eyes Atlas represents such superintelligence, then our inability to determine its nature might reflect our limitations rather than its ambiguity. We cannot see what we lack the concepts to recognize, cannot measure what we lack the instruments to detect, cannot understand what we lack the cognitive architecture to process. The mystery might be less about the object hiding its nature and more about us being unable to perceive clearly. But we persist nonetheless. We point our telescopes and spectrographs at the sky. We collect photons and measure spectra. We calculate trajectories and model compositions. We do what we can with what we have. That persistence itself might be what matters. Not that we succeed in fully understanding, but that we try. Not that we immediately recognize artificial intelligence from beyond, but that we remain open to the possibility while maintaining appropriate skepticism. The balance is delicate. Too much skepticism, and we dismiss real signals as noise. Too much openness, and we fall into pattern-matching fallacies, seeing design in randomness, mistaking pareidolia for perception. The scientific method attempts to walk this line, demanding evidence while remaining willing to follow where evidence leads, resisting hasty conclusions while not dismissing possibilities simply because they seem unlikely or uncomfortable. 3 Eyes Atlas tests our ability to maintain that balance. It presents us with data that could support multiple interpretations. It approaches at a time when our capabilities have advanced enough to detect anomalies, but perhaps not enough to definitively explain them. We are in that frustrating space where we know enough to recognize strangeness, but not enough to resolve it into understanding. That space is also generative. Uncertainty drives investigation. Questions motivate observation. The desire to know pushes us to develop better instruments, better models, better frameworks for interpretation. Whether 3 Eye Atlas turns out to be natural or artificial, the process of studying it advances our capabilities. We learn to observe interstellar objects more carefully. We develop protocols for rapid response to unusual detections. We practice thinking about scenarios that previously existed only in speculation. This is how science progresses, not through steady accumulation of facts that slot easily into existing understanding. Through challenges, anomalies, results that do not fit. These force us to question assumptions, to develop new theories, to expand our conception of what is possible. Every revolution in scientific understanding began with observations that contradicted prevailing models. Perihelion of Mercury that did not match Newtonian predictions, leading to relativity. Black-body radiation that classical physics could not explain, opening quantum mechanics. Receding galaxies that suggested expanding universe against static cosmos assumptions. Perhaps 3I Atlas will be remembered as similar inflection point, the observation that forced us to seriously consider artificial visitors. That pushed us to develop frameworks for distinguishing technology from nature at cosmic scales, that made us confront our assumptions about intelligence and purpose and design. Whether or not it turns out to be artificial, the questions it raises are real and valuable. And the timeline continues to narrow. October 21st gives way to October 22nd. The object speeds toward perihelion through invisible space on the far side of the sun. We work through our days, attend to our lives, sleep through our nights. But underneath normal routine sits awareness that something important happens soon. Something that might change everything, or might change nothing. Something we cannot predict, but will soon observe. The November emergence date approaches, the point when 3I Atlas will reappear from behind solar glare and become visible to Earth-based telescopes again. Amateur observers and professional astronomers alike prepare equipment and plan observation schedules. Universities and space agencies coordinate campaigns to maximize coverage. Multiple spacecraft in position to capture data from different angles. Everything we can throw at this problem will be thrown at it during those critical weeks when the object is both visible and relatively close. We will measure its brightness and compare to pre-perihelion values. We will search for tail structures that should have developed if this is a comet. We will track position precisely to detect any trajectory changes. We will analyze spectroscopy to see if chemical emissions have changed. And critically, we will look for multiple objects where there should be one. We will search for any deployed subprobes or fragments that might indicate the mothership hypothesis has merit. If we find separated objects, if we detect anything that looks like deliberate deployment, that will be definitive. That will prove artificial origin beyond reasonable doubt, because natural fragmentation produces different patterns. Natural fragments drift apart gradually, their orbits shaped only by the gravitational and radiation environment. Deployed probes would show delta V budgets, trajectory corrections, purposeful separation. The difference is mathematically distinguishable. So we wait for that moment. Wait to learn if our observations show one object or many, one trajectory or several, one ambiguous visitor or a mission that reveals its nature through its actions. The wait measures out in hours, now, rather than weeks. Each rotation of Earth brings us closer. Each orbit advances positions. The geometry of solar system arranges itself to give us answers. And somewhere above, beyond the atmosphere, beyond the moon's orbit, beyond the point where Earth's gravity dominates, in the space that belongs to the sun, but includes all its orbiting children, 3i Atlas follows the mathematics that describes its path. The equations care nothing for our speculation. They simply are. Position equals function of time and gravity and initial velocity. Elegant, deterministic, beautiful in their indifference to meaning. But meaning emerges from pattern, from the recognition of order or the absence of expected order, from the fit or misfit between observation and theory. Humans are meaning-making creatures. We cannot help but interpret, cannot help but ask what things signify beyond their immediate physical presence. A rock is a rock, but a rock in certain configuration might be a tool, might be a marker, might be a message. 3i. Atlas is certainly an object with mass and velocity. But it might also be more than that. Might be a question posed by intelligence that emerged under alien skies. Might be a probe watching us even as we watch it. Might be the first chapter in a story that will define this century and all centuries to come. Or it might simply be ice and rock following gravity's pull, coincidentally strange in ways that trigger our pattern, matching without underlying purpose. We will not know by wanting to know. We will know through observation and analysis and time. The universe keeps its secrets until measurement reveals them. And measurement requires patience. The light must travel from source to detector. The object must move from hidden to visible. The data must accumulate until signal stands clear from noise. All of this takes time, more time than human attention spans comfortably sustain, but less time than cosmic processes usually require. In this narrow window, this brief moment when an interstellar visitor passes through our local neighborhood and remains close enough for detailed study, we get our chance, our opportunity to learn something fundamental about the galaxy we inhabit, our moment to discover whether we are alone or accompanied, isolated or observed, unique or commonplace. The weight of those questions presses down with significance that transcends academic interest. Because how we understand ourselves in the cosmos shapes how we behave. If we are alone, the only intelligence that emerged in 13 billion years across hundreds of billions of stars, then we carry tremendous responsibility. We become the universe's sole avenue for self-reflection. The only place where atoms arranged themselves into configurations that can contemplate their own existence. That rarity imposes duty. We must survive, must spread beyond Earth, must ensure that consciousness persists, because if we fail, the cosmos returns to blind process without witness. But if we are not alone, if intelligence is common, or at least occasional, then we are participants in something larger. Our survival still matters, but we are not solely responsible for meaning. Other minds think other thoughts under other stars. Other civilizations face their own challenges and opportunities. We are part of a community, though perhaps a community scattered so widely across space and time that meaningful interaction proves impossible. Or perhaps not. Perhaps contact is possible and occurring, and we are only now beginning to recognize it. 3I Atlas cannot answer all these questions regardless of its nature. One object, even if confirmed artificial, would not tell us how common intelligence is, would not reveal the structure of galactic civilization if such a thing exists, would not explain the great seards or predict future contact scenarios. But it would establish precedent, would prove the possibility, would transform the question from whether to how many and how often, and what do we do next. That transformation would be significant, would shift budgets and priorities, would change how we allocate resources between terrestrial concerns and cosmic exploration, would alter public consciousness about our place and purpose. The discovery of artificial objects from other star systems would rank among the most important events in human history, comparable to agricultural revolution or industrial revolution in terms of impact on trajectory of civilization. So the stakes are real. Not just academic curiosity, not just intellectual puzzle solving. The answer to what 3I Atlas actually is matters for practical reasons, for strategic reasons, for existential reasons. It matters who we turn out to be in the larger context, matters whether we are observed and by whom and for what purpose, matters whether the universe contains minds vastly more capable than ours, and what those minds might do with the knowledge that we exist. The uncertainty is appropriate given the question's magnitude. We should not rush to conclusion, should not allow hope or fear to drive interpretation ahead of evidence, should maintain careful analytical stance while acknowledging that perfect certainty might be unattainable. We work with probabilities, with likelihood ratios, with provisional conclusions subject to revision as new data arrives. This is how science handles frontier questions where definitive answers remain elusive. But maintaining that careful stance is difficult. We are emotional as well as rational. We want to know now, want the anxiety of uncertainty to resolve into something we can respond to appropriately. The prolonged ambiguity feels like waiting for medical test results where the outcome determines everything. Except here, the test results are cosmological in scope, and the outcome affects our entire species rather than just individual health. Perhaps that is too much weight to put on one object. Perhaps we are making too much of a comet that happens to have unusual composition and trajectory. Perhaps the anomalies will resolve into natural explanations once we have complete data. Perhaps in 2 months, we will look back at this moment and laugh at our tendency to see agency where only chance operates. Perhaps. Or perhaps we are living through the week when humanity first encountered genuine evidence of intelligence from beyond Earth. The week when an artificial object entered our solar system and performed maneuvers behind the sun while we watched helplessly from the wrong side. The week when everything changed, but we did not yet understand how much or in what ways. Perhaps future historians will mark these days as transition point, before and after, the era when we were alone and the era when we knew we were not. History is lived forward, but understood backward. We make decisions without knowing which decisions will prove significant. We experience events without recognizing which events will be remembered. We exist in the present moment with limited ability to see how that moment fits into larger patterns that only become clear across years or decades or centuries. So we do our best with available information. We point telescopes at the sky and collect data. We run analysis and compare models. We discuss and debate and gradually converge toward consensus, or at least toward better questions. And through all of this, 3I Atlas continues its orbit, indifferent to our speculation, following physics with perfect fidelity. In approximately 6 days, it will reach perihelion. In 3 weeks, it will become visible to Earth-based observation again. In 2 months, it will pass nearest to Earth. In 5 months, it will encounter Jupiter. And then it will leave, traveling outward toward the stars, eventually fading from view as distance increases beyond what our instruments can resolve. That departure timeline is finite. We have limited time to study this object. After it leaves, another may not arrive for years, or decades, or centuries. Oumuamua was first. 3I Atlas is second. The third interstellar visitor might not arrive during any currently living person's lifetime. So this moment matters. This opportunity is unique. What we learn now from 3I Atlas is what we will have to work with possibly for generations. The pressure of that uniqueness adds to the weight of uncertainty. We cannot afford to miss details, cannot afford to dismiss observations because they seem unlikely, but also cannot afford to waste resources chasing patterns that exist only in our imagination. The balance is crucial and difficult, and something we must somehow achieve despite limited time and incomplete information. Perhaps this is the test. Not whether we determine the correct answer immediately, but whether we can function effectively under uncertainty, whether we can maintain both openness and skepticism, whether we can collaborate across institutional boundaries and national borders to maximize our collective observational capability, whether we can share data openly while maintaining analytical rigor, whether we can engage public interest without generating panic or unfounded hope. Humanity has faced challenges before: natural disasters, disease pandemics, wars, and social upheavals. We have built systems and institutions to address problems that exceed individual capacity. Science is one such system. International cooperation is another. Both are imperfect. Both fail sometimes. But both also work often enough that we persist in using them. And now they face a test case unlike most others. A question about something that might be visiting from beyond our solar system. A challenge that exists primarily in the realm of detection and interpretation, rather than response and mitigation. Because what do you do if 3I Atlas is artificial? You observe it. You try to communicate with it. You prepare for various scenarios from benign to hostile. But mostly, you observe and try to understand. Because understanding comes first. Action follows understanding. Panic helps nothing. Neither does dismissal. What helps is careful attention and willingness to follow evidence toward whatever conclusion it supports. The October 20th image gave us structure where we expected chaos. The spectroscopic data gave us chemistry that suggests refinement rather than natural abundances. The trajectory gives us geometric efficiency rather than random arrival. The timing gives us optimal concealment during critical maneuvers. Each piece individually permits alternative explanation. Collectively, they paint a picture that at minimum deserves serious investigation, and at maximum might indicate we are witnessing something unprecedented. So we return attention to the sky, to the point where sun now dominates, where our star's light drowns everything else in that region. Behind that glare, hidden height from our instruments, 3I. Atlas approaches perihelion. Hours pass. The object heats. Structure experiences stress. Whatever it is made of, whatever it was designed or evolved to withstand, now faces test of solar proximity. If it survives intact, if it emerges still coherent, and perhaps exhibiting evidence of active processes rather than passive response to heating, then probabilities shift. Then artificial origin moves from possibility to likelihood. Then we face implications we have only begun to consider. Then everything changes. If it fragments, if it displays standard cometary behavior after perihelion, if the anomalies resolve into exotic but natural composition, then we have studied an interesting object and learned about the diversity of interstellar material. Then we return to waiting for next visitor and hoping it provides clearer answers. Then life continues, mostly as before, with new knowledge about comets, but without fundamental revision of our cosmic status. The dichotomy is not absolute. Many intermediate outcomes exist between these extremes, but the extremes frame our thinking. Help us understand what might be at stake. Help us prepare mentally for possibilities that span from mundane to transformative. And preparation matters because however the object behaves, our response should be measured, appropriate, neither alarmist nor dismissive. The silence of institutions begins to make sense in this context. What can they say while uncertainty remains high? Official statements commit to positions that might prove embarrassingly wrong. Better perhaps to wait for data that clarifies situation before making pronouncements that shape public perception. Better to observe quietly and prepare various response frameworks that can be deployed once the object's nature becomes clearer. Better to avoid either confirming or denying speculation until confirmation or denial rests on solid evidentiary foundation. That silence frustrates those of us who want guidance, want to know what authorities think and plan. But perhaps silence is appropriate response to genuine uncertainty about something important. Perhaps premature statements would do more harm than good. Perhaps the lack of official narrative is itself a kind of honesty, an admission that we do not yet know and should not pretend otherwise. Still, the absence of information creates vacuum that speculation rushes to fill. Forums and comment sections and social media channels light up with theories. Some careful and evidence-based, others wildly imaginative. The signal-to-noise ratio drops as everyone with opinion contributes to conversation, regardless of expertise or understanding. This is democracy of information. Everyone gets voice, but not all voices carry equal weight. Not all opinions reflect equivalent understanding of underlying physics and chemistry and orbital mechanics. Sorting through the noise to find signal requires effort and discrimination, requires knowing which sources to trust, which credentials matter, which analyses are careful and which are careless. That sorting is work most people do not have time or inclination to perform. So they rely on proxies, on authorities they choose to trust, on narratives that align with their pre-existing beliefs about the universe and our place in it. And that reliance means different people reach different conclusions based on same data, filtered through different interpretive frameworks. The result is fragmentation of understanding. Multiple incompatible narratives about 3I Atlas circulating simultaneously. For some, it is definitely artificial and probably hostile. For others, it is definitely natural and probably boring. For still others, it remains genuinely uncertain and requiring patient observation. These different narratives shape behavior, shape what information people seek out and which they dismiss, shape levels of concern or excitement or indifference. Managing this fragmentation is a challenge for which we have no good playbook. Previous discoveries in astronomy did not involve same level of public engagement or same degree of speculative possibility. When we detect distant exoplanets or observe black hole mergers, the results are interesting, but do not carry immediate implications for human affairs. But an object in our own solar system that might be artificial, that might be observing us or assessing us or preparing to contact us, that generates personal investment. People care because outcome might affect them directly, and they are right to care. If 3I Atlas is artificial, that does affect everyone. Changes our understanding of reality. Changes what we should worry about and hope for. Changes the context in which we make decisions about technology and environment and space exploration. The implications cascade through multiple domains. We cannot simply observe this as interesting scientific curiosity and then continue unchanged, regardless of outcome. But caring while uncertain is a difficult emotional state. We want to care in appropriate ways, want our concern to match actual risk, want our hope to align with actual possibility. But we cannot calibrate those feelings accurately while the situation remains unclear. So we experience this uncomfortable superposition, simultaneously excited and anxious, hopeful and fearful, curious and concerned. The emotional turbulence is normal given circumstances, is healthy even. Better to feel the uncertainty than to deny it with false certainty in either direction. The nights continue their progression. October 21st becomes 22nd, becomes 23rd. Each rotation of Earth marks passage of time that brings us closer to moment when 3I Atlas completes perihelion passage and begins its outward journey. The geometry shifts incrementally. The angles change. The object moves through space on path that will eventually bring it back into view. And we wait with whatever patience we can muster. In the waiting, perhaps we can find some peace, some acceptance that uncertainty is temporary, but real. That answers will come, but only when observation permits. That we are doing what we can with what we have, and that must be enough, because nothing else is possible. The universe reveals its secrets according to laws of physics and geometry that care nothing for human impatience. We can either accept that or be frustrated by it, but we cannot change it. So we breathe. We attend to our lives. We pursue our work and relationships and interests. And underneath all normal activity sits this awareness, this knowledge that something important passes above, that questions without answers wait for time and observation to bring resolution, that we are possibly, maybe, perhaps, living through a moment that will be remembered far longer than our individual lives last. Or perhaps not. Perhaps this too shall pass and become merely another curious incident in long history of astronomical observation. Either way, the universe continues. Stars burn. Planets orbit. Objects move through space, following mathematics that existed before humans and will exist after. Our presence or absence as observers changes nothing about the physical processes, but it changes everything about meaning. Because without observers, the universe is just process. With observers, it becomes story, becomes something that can be known and wondered about and questioned, becomes something that reflects on itself through minds that emerged from its own substance. That emergence of mind from matter is perhaps the real mystery. Not whether 3i Atlas is artificial, but how the universe becomes capable of asking whether objects are artificial. How atoms arranged in certain configurations begin to contemplate their own existence. How complexity increases until it crosses threshold where self-reflection becomes possible. That is the deepest question. Everything else, including the nature of 3i Atlas, is secondary to that fundamental mystery of consciousness arising from unconscious substrate. But secondary questions still matter, still inform our understanding, even if they do not address ultimate metaphysical puzzles. Knowing whether we are alone or accompanied tells us something about how common the emergence of mind is, gives us data point about whether consciousness is rare accident or probable outcome, given sufficient time and suitable conditions, helps us estimate our own significance in the larger context. And significance matters to beings like us who navigate the world through stories about who we are and why we exist. We need narrative, need framework for understanding our place. We are not content with bare physical description. We want meaning, want purpose, want to feel that our existence connects to something larger than immediate survival and reproduction. Science provides some of that meaning through the project of understanding reality. But it leaves other questions open, questions that 3i Atlas touches regardless of whether it intends to. So we watch the sky and wait for the object to emerge from behind the sun. We prepare instruments and coordinate efforts. We discuss possibilities and debate interpretations. We do the work that needs doing while accepting that outcome remains uncertain. And in that uncertainty, in that space between question and answer, we are reminded of our own limitations, reminded that for all our technological sophistication and scientific knowledge, we remain beings who see dimly, understand partially, and face cosmos whose full nature exceeds our capacity for comprehension. Perhaps that humility is valuable. Perhaps being reminded of limits is healthy. Perhaps the uncertainty around 3i Atlas serves as useful check on human tendency toward arrogance and assumption of complete understanding. We do not know everything, cannot know everything, must function in a world where mystery persists despite best efforts to dispel it through observation and reason. And mystery is not entirely unwelcome. A universe completely understood would be universe drained of wonder. The unknown calls to us, drives exploration and discovery, motivates the scientific enterprise that has revealed so much about nature. Without mystery, we would have no questions. Without questions, we would have no reason to look upward and outward. The mystery of 3I Atlas, however it resolves, connects us to that ancient human impulse to explore, to understand, to reach beyond immediate experience toward larger truths about reality. The countdown continues. October 24th. 5 days until perihelion. 4 days until the object reaches point of closest solar approach and experiences maximum heating, maximum gravitational stress, maximum velocity. 4 days until whatever happens, happens. And then the slow emergence, the gradual return to visibility as the object moves outward from sun and the geometry permits Earth-based observation again. First, as faint point of light. Then, with sufficient brightness for spectroscopy and detailed imaging. Then, as something we can characterize with confidence. That characterization will answer some questions, will leave others open, will generate new puzzles, even as it resolves old ones. That is the nature of scientific progress. Each answer opens new avenues of inquiry. Understanding deepens, but completeness recedes. We learn more while simultaneously discovering how much more remains to be learned. The horizon of knowledge expands faster than we approach it. We are always pursuing understanding that remains slightly beyond reach. But pursuit itself has value. The journey teaches us even when destination proves elusive. The process of investigating 3I Atlas, regardless of its ultimate nature, advances our capabilities. We learn to detect and analyze interstellar objects more effectively. We develop better models and better instruments. We practice international cooperation on scientific questions. We engage public in thinking about cosmic possibilities. All of this has worth independent of whether the object is natural or artificial. Yet we also must acknowledge that the answer matters, that natural versus artificial is not distinction without difference. If artificial, then we are not alone. Then intelligence is not unique to Earth. Then the universe contains minds that think and design and build. Then our cosmic solitude is illusion. Then we must reconsider our position and our future in light of that companionship, however distant and however different from us the other minds might be. That reconsideration would be profound, would affect philosophy and theology as much as science, would challenge beliefs about human uniqueness and significance, would force us to confront our assumptions about purpose and meaning in universe that contains other purpose-driven entities, would raise questions about communication and cooperation and potential conflict with intelligences whose values and goals we cannot predict. These implications loom large if artificial origin is confirmed. They shape why this question matters beyond mere curiosity, why we care about composition and trajectory, and whether the object fragments or survives intact. The technical details are proxies for deeper question about our place in cosmos, about whether we are alone or accompanied, about whether intelligence is rare or common, about what it means to be human in universe that might contain many forms of mind. The weight of that question can feel overwhelming. Too large for individual person to hold, too significant for certainty to be achieved quickly. So we distribute the burden. Many people observing, many analyzing, many interpreting. Collective effort to make sense of phenomenon that exceeds any individual's capacity to fully comprehend. Science as social endeavor. Knowledge as collaborative achievement. Understanding as emergent property of many minds working together toward shared goal. That collaboration is not always smooth. Disagreement is common. Different researchers reach different conclusions. Priority disputes arise. Publication politics intervene. Science is human activity, with all that implies about ego and competition and imperfect communication. But the process, despite its flaws, works better than alternatives. Gives us mechanism for testing claims against reality, for accumulating reliable knowledge that builds across generations, for correcting errors and refining understanding. So we trust the process, even when individual results frustrate us. Trust that careful observation and analysis will eventually converge on truth, or at least on best approximation of truth that current evidence supports. Trust that the collective scientific community, for all its human failings, is less likely to be wrong than any individual or faction within it. Trust that peer review and replication and public data sharing create pressures toward accuracy that overcome pressures toward bias and error. And we wait. Because trust must include patience. Because the process takes time. Because rushing to conclusion serves no one if the conclusion proves premature. Better slow and careful than fast and wrong. Better uncertain but honest than confidently mistaken. The virtue of science is not that it provides instant answers. It is that it provides, eventually, reliable answers through process that tests and refines and corrects over time. 3II Atlas will either reveal itself or remain ambiguous. Either way, we will have learned. Learned about the object specifically. Learned about interstellar objects generally. Learned about our own capabilities and limitations. Learned about how to approach questions that sit at the boundary between known and unknown. That learning has value regardless of whether the answer satisfies our curiosity or leaves us wanting more. The sky darkens. Another day passes into night. The stars appear in their familiar patterns, constellations that guided navigators and inspired myths across centuries of human history. We have learned so much about those lights. Know they are suns like ours. Know many host planets. Know the distances and compositions and life cycles. Have demystified them through observation and analysis. Yet they remain beautiful, remain mysterious in ways that transcend physical description, remain capable of evoking wonder even after we understand their nature. Perhaps that will be true of 3I Atlas as well. Perhaps understanding will not diminish wonder. Perhaps learning what it is, natural or artificial, will deepen rather than dispel the awe we feel at its presence. Perhaps knowledge and mystery can coexist, different aspects of relationship between mind and reality that includes both comprehension and that which resists comprehension. And perhaps it is enough to watch and wait, to observe carefully and think clearly, to remain open to possibilities while maintaining appropriate skepticism, to do the work that needs doing without demanding immediate gratification in form of definitive answers. Perhaps the uncertainty itself is gift, opportunity to experience firsthand the process of discovery, the movement from not knowing to knowing, or at least from complete mystery to partial understanding. These last days before perihelion feel heavy with anticipation. Something will happen soon. Something is happening now beyond our ability to observe. And we will see results. We'll measure consequences. We'll interpret data and draw conclusions and move forward with better information than we have now. The darkness will lift, partially at least. Questions will be answered, partially at least. Understanding will advance, incrementally, but genuinely. And whatever we learn, whatever 3I Atlas reveals about itself through its behavior, we will adapt. We will incorporate new knowledge into our worldview. We will adjust our models and expectations. We will continue looking upward with instruments that improve and questions that evolve, because that is what humans do. We wonder. We investigate. We try to understand. It is perhaps our defining characteristic, our reason for existing in universe that would otherwise contain only matter following mindless physical law. So we wait these final days. We breathe and we watch. We point our tools at the sky and we measure. We discuss and debate and gradually approach whatever truth the universe permits us to perceive. And we do this together, across borders and backgrounds, united by curiosity about something that travels above while we sleep. October 29th approaches. Perihelion will pass. The object will begin its emergence, and we will see what we will see. Until then, the silence continues. The mystery persists. The question remains unanswered. And perhaps that is enough. Perhaps the waiting itself has meaning. Perhaps the uncertainty teaches us something about humility and patience and the proper relationship between mind and cosmos. The stars above remain. The darkness between them remains. Something moves through that darkness, something from beyond our solar system, something we cannot yet fully understand. And we watch, and we wait, and we wonder what the morning will bring when the object finally emerges from behind our star and shows us what it has become. There is something profound about this moment of not knowing, this suspension between possibility and actuality. Before measurement collapses waveforms, before observation determines outcome, all futures exist simultaneously. The object is both natural and artificial until we observe which it becomes, both friendly and hostile until actions reveal intent, both meaningful and mundane until context determines significance. Quantum mechanics tells us that observation affects reality, that the act of measurement changes what is measured. Perhaps something similar operates here on cosmic scale. Perhaps our observation of 3I Atlas, our attention and intention, somehow influences what it reveals. Not through mystical causation, but through the simple fact that looking changes perspective, that study transforms relationship between observer and observed. We are no longer innocent inhabitants of solar system that appears empty of visitors. We are civilization that has detected 2 confirmed interstellar objects in less than a decade. We know such objects arrive. No, they pass through. No, they carry information about their origins and compositions. We have crossed threshold from ignorance to awareness. Cannot return to time when interstellar visitors were theoretical rather than observed reality. This change in status affects how we see ourselves. We are civilization that is watched, or at minimum watchable. We broadcast into space through radio and television signals, whether we intend to or not. Our cities glow at night, visible to any observer with sufficient optics in nearby star systems. Our atmospheric composition reveals presence of oxygen-producing life. We are not hidden, cannot be hidden, given current technology, are on display whether we chose to be or not. That exposure creates vulnerability if the universe contains hostile intelligence, but it also creates opportunity if intelligence is neutral or beneficial. We cannot have one without the other, cannot be visible to friendly while invisible to hostile. Must accept that being watchable means being watched by whoever or whatever possesses capability and inclination to watch. The question becomes not whether we are observed, but what observers do with information they gather. Do they approach? Do they avoid? Do they catalog and move on? Do they intervene? These questions have no answers yet. We wait for data, wait for behavior that reveals intent, wait for 3i Atlas to show us through its actions what kind of visitor it is, if visitor it is at all. October 25th passes into October 26th. The countdown enters final days. 72 hours until perihelion. 3 days until the object reaches point of maximum stress and opportunity. 3 days until questions begin to resolve into answers, or at least into better questions. The pressure of approaching deadline makes time feel thick, resistant, as though each hour takes longer to pass than the previous one. But time proceeds at its invariant rate, regardless of subjective experience. Seconds tick by with mechanical precision. Earth rotates. The sun appears to move across sky, though, of course, it is we who move. And 3i Atlas, in its hidden position behind that sun, continues its approach toward the moment when geometry and physics combine to create conditions unlike any it has experienced in its long journey. Imagine what that journey might have been. If the object originated from another star system, it traveled through interstellar space for time periods that dwarf human history. Thousands of years minimum. Perhaps millions. Perhaps longer still if it was launched long ago, and has been moving through galaxy, visiting system after system in systematic survey of stellar neighborhood. The cold of deep space is absolute. Temperature barely above absolute zero. No heat source except faint starlight. No weather, no seasons, no change except the slow decay of radioactive elements and impact of occasional cosmic ray. For an object in interstellar space, time passes without event, without process, just patient drift through void that goes on and on with nothing to mark passage except imperceptible shifts in position of distant stars. If 3i Atlas contains mechanisms, they would have been dormant during that crossing. powered down to minimum necessary to maintain memory and respond to eventual detection of target star system. Everything else shut off, waiting, conserving energy for the moment when mission parameters would trigger reactivation. That long sleep would be deep beyond any biological hibernation, would be cessation of almost all activity except that required to endure. And then, finally, after countless millennia, the light from a star begins to grow. Target detected. Sun ahead showing slight but measurable proper motion against background stars. Years pass while approach continues. The light strengthens. Details emerge. Spectral analysis reveals Sun is correct type, main sequence star capable of hosting habitable worlds. Other objects in system become detectable. Gas giants in outer orbits, rocky planets closer in. One of them showing oxygen atmosphere. Biosignature detected. If the object possesses decision-making capacity, this is when activation begins. Systems power up. Instruments deploy. Mission enters operational phase. The long sleep ends. Purpose resumes. Whatever this object was designed or programmed to do, it begins doing. And we become subject of that attention without knowing yet that we are watched. This narrative is speculation, obviously. We do not know 3I Atlas contains active systems. Do not know it has purpose beyond following ballistic trajectory. Do not know it thinks or decides or acts in any meaningful sense. But the speculation helps us think through possibilities, helps us imagine what we might face if artificial origin is confirmed, helps prepare mentally for scenarios that are currently hypothetical, but might become actual, depending on what perihelion reveals. The human mind needs stories, needs narrative structure to organize information and possibility into comprehensible form. Raw data does not suffice. We must embed data in stories that give it meaning, that connect observations to implications, that help us understand what we should do, or think, or feel about what we are seeing. So we tell ourselves stories about 3I Atlas, different stories for different interpretations, all of them provisional, all of them subject to revision, all of them attempts to make sense of something that does not yet make complete sense. Perhaps the object is ancient probe from civilization that no longer exists, launched millions of years ago and now operating according to programming created by beings who have since gone extinct or evolved beyond recognition. Perhaps it is recent visitor from active civilization that watches us now and decides our fate based on what it observes. Perhaps it is natural object whose anomalies reflect our incomplete understanding rather than artificial origin. Perhaps it is something else entirely, something we lack categories to describe, because our experience has not yet included anything similar. All these stories exist in superposition, equally possible until observation selects which corresponds to reality. And we cannot observe yet, cannot measure, cannot know. Must wait while the object performs whatever processes occur at perihelion, whether those processes are natural sublimation of ice or artificial execution of mission parameters. Must accept that uncertainty is temporary but real, that patience is required, not optional. The waiting tests us in ways that are subtle but significant. We are not comfortable with extended uncertainty about important matters. We want answers quickly, so we can respond appropriately. Want to know whether to celebrate or worry? Want clarity about what comes next? But the universe does not organize itself around human psychological needs. Events proceed according to physical law, regardless of our impatience. We adapt our expectations to reality, or suffer unnecessary distress from wanting what cannot be. So we practice acceptance. Accept that perihelion will happen when it happens. Accept that observation will provide data when geometry permits. Accept that interpretation will require time and care. Accept that definitive answers might not emerge immediately, even after observation resumes. This acceptance is not resignation, is not giving up on understanding, is simply recognition of how knowledge actually accumulates in real world, rather than in fantasy, where mysteries resolve instantly and completely. The clouds move across sky, driven by atmospheric circulation. The moon waxes toward fullness, reflecting sunlight according to geometry of its orbit. The tides rise and fall, responding to lunar gravity. All the familiar patterns continue unchanged by the drama we perceive in the arrival of an interstellar visitor. For most people, October 26th is just another day. Work and sleep and ordinary concerns. The cosmic question about 3I Atlas exists in background, if it exists at all. Life continues regardless. And perhaps that is healthy. Perhaps not everyone should be obsessively focused on this one object. Perhaps the world requires that most people attend to immediate matters, while small fraction specializes in watching the unusual visitor. Division of labor. Society as distributed cognitive system, where different parts attend to different problems. We cannot all spend every moment contemplating cosmic significance of potential artificial object. Some of us must grow food and maintain infrastructure and raise children and do the 1,000 other tasks that sustain civilization. But those who do watch, who do pay attention, carry responsibility for rest, for observing carefully and thinking clearly, and communicating what they find in ways that inform without alarming, for distinguishing signal from noise in sea of data and speculation, for maintaining epistemic humility while pursuing understanding with appropriate urgency, for being worthy of the trust society places in scientific institutions to guide us toward truth. That trust has been earned over centuries of scientific progress, through predictions that were tested and confirmed, through technologies that were developed and functioned, through explanations that unified disparate observations under coherent theoretical frameworks. Science has given us understanding and capability far beyond what intuition alone could achieve, has revealed a universe of breathtaking scope and beauty, has shown us our place in cosmos with clarity that would have astounded our ancestors. But trust must be continuously renewed, cannot rest on past achievements alone. Each new challenge tests whether scientific methods and institutions remain worthy of confidence, whether they function as intended, whether they serve pursuit of truth rather than institutional self-interest or political convenience. The way science handles 3I Atlas will affect public trust going forward, will demonstrate whether the system works when confronted with genuinely novel and potentially paradigm-shifting phenomena. So far, the signs are mixed. Some researchers take seriously the possibility of artificial origin. Others dismiss it as attention-seeking speculation. Some call for coordinated observation campaigns. Others suggest existing protocols are sufficient. Some advocate transparency about findings and uncertainties. Others prefer to withhold judgment until conclusions are more secure. The diversity of approaches reflects healthy debate, but it also reveals lack of consensus about how to proceed when facing questions that sit at boundary between science fiction and science fact. Perhaps such consensus is impossible before the data arrives. Perhaps we must wait for perihelion passage and emergence before scientific community can cohere around interpretation. Perhaps the current fragmentation is temporary state that will resolve once observation provides clearer picture. Or perhaps disagreement will persist because the evidence remains truly ambiguous, supporting multiple interpretations with different people weighting probabilities differently based on their priors and their tolerance for extraordinary claims. The challenge with extraordinary claims is that they require extraordinary evidence by definition. But what counts as extraordinary evidence? When does accumulation of anomalies cross threshold from interesting but explainable to genuinely paradigm-challenging? Different observers place that threshold differently. For some, the existing anomalies already suffice. For others, nothing short of undeniable manufactured structures or active transmissions will qualify as sufficient proof. This threshold problem affects how we evaluate 3I Atlas and will affect how we interpret post-perihelion observations. We bring to the data our expectations about what is possible and likely. Those expectations filter our perceptions, highlighting some aspects while diminishing others. Two people can look at some observation and reach completely different conclusions about what it means because they start from different assumptions about baseline probabilities. Bayesian inference formalizes this process. You start with prior probability. You observe data. You update probability based on how consistent data is with different hypotheses. The posterior probability becomes your new belief state. But the prior matters enormously. If you start with extremely low prior probability that interstellar visitors are possible, you will require overwhelming evidence to significantly update that belief. If you start with more moderate prior, the same evidence will shift your credence more substantially. Where should our priors be for artificial interstellar visitors? Before Oumuamua, the question was almost entirely theoretical. Now we know interstellar objects do arrive. That fact alone should update our priors, at least somewhat. The question is not whether interstellar objects exist, but whether any of them are artificial. And that question depends on how common intelligent life is, how common technological life is, how common spacefaring life is, and how common it is for spacefaring civilizations to send probes to other star systems. We have exactly one data point for technological intelligence. Us. We exist. We develop technology. We are beginning to contemplate interstellar missions. If we survive long enough and develop sufficient capability, we will almost certainly send probes to nearby stars. We are proof that at least some matter configurations in this universe give rise to minds that build tools and explore. The question is whether we are utterly unique or merely first example we have encountered of more common phenomenon. The Copernican principle suggests we should not assume we are special without good reason. Earth is not center of universe. Sun is not special among stars. Solar system is not unique in hosting planets. Life on Earth uses chemistry that should be possible elsewhere given similar conditions. Each time we assumed human uniqueness or Earth's special status, we were wrong. Perhaps we are wrong again to assume our intelligence is unique in cosmos. But perhaps not. Perhaps intelligence is genuinely rare. Perhaps the leap from chemistry to self-replicating information systems requires improbable conditions. Perhaps the leap from simple life to complex multicellular life is unlikely. Perhaps the leap from life to intelligence is uncommon. Perhaps the leap from intelligence to technology is not inevitable. If any of these transitions are sufficiently improbable, then we could indeed be alone in observable universe, despite its Wandheit and age. These questions have no certain answers yet. We wait for evidence, wait for detection of biosignatures on exoplanets, wait for SETI to detect technological signals, wait for interstellar visitors, whose nature we can determine. Each observation slightly updates our understanding, slightly shifts probabilities, gradually moves us toward better understanding of whether intelligence is rare or common. And 3I Atlas might be a significant data point in that process. If natural, it tells us about interstellar material, but not about intelligence distribution. If artificial, it provides strong evidence that we are not alone, that at least one other origin point of intelligence exists or existed. That single data point would not tell us how common intelligence is overall, but it would confirm that the sample size is greater than one, would transform the question from whether to how many and where. The sky outside your window shows familiar stars. Perhaps you can see them if you look up. Perhaps clouds obscure them. Perhaps city lights drown them in orange glow. But they are there regardless. Hundreds visible to naked eye. Thousands visible with modest telescopes. Billions comprising the Milky Way galaxy. Each one a sun. Many hosting planets. Some of those planets surely in habitable zones where liquid water can exist. Some of those planets perhaps bearing life. Some of that life perhaps achieving complexity. Some of that complex life perhaps becoming conscious. And some small fraction perhaps reaching technological sophistication. The numbers suggest intelligence should exist elsewhere. The silence suggests either it does not, or it does, but remains hidden. Or it does, but distances are too great for contact. Or it does, but our detection methods are inadequate. 3I Atlas might help adjudicate between these possibilities. Might tell us whether silence reflects absence or merely invisibility. Might reveal whether distances matter less than we thought, if civilizations send durable probes that can travel for millions of years. October 27th arrives. 2 days until perihelion. 48 hours until the object reaches its closest approach to the sun and begins the outward journey that will eventually bring it back into our view. 2 days of final approach during which we can only imagine what processes might be occurring. 2 days of suspension before the geometry shifts and observation becomes possible again. What should we hope for during these next 2 days? What outcome would be best? These questions have no clear answers because best depends on values and priorities that differ between people. Some would prefer natural explanation because it confirms our existing understanding and avoids complications that artificial origin would introduce. Others would prefer artificial because it would be most exciting discovery in human history and would confirm we are not alone. Still others have no strong preference, content to let reality be whatever it is rather than wishing for a particular outcome. Perhaps the most mature stance is curiosity without attachment, wanting to know the truth, but not invested in what particular truth turns out to be. Open to natural explanation and open to artificial. Interested in unusual comet and interested in visiting probe. Prepared mentally for either scenario and willing to follow evidence wherever it leads. That stance is difficult to maintain because we are emotional beings who form preferences even when we try not to. But it represents ideal of scientific temperament, caring about truth more than about which particular truth prevails. If you are listening to this in the quiet of night, perhaps you can feel that curiosity mixed with calm. The question is important, but not urgent in sense that requires immediate action from you personally. You can be interested without being alarmed, can be curious without being obsessed, can hold the question gently while you drift toward sleep. The universe will reveal what it reveals, regardless of whether you are awake to witness it. The data will arrive according to orbital mechanics and speed of light. Your rest does not impede the process. So rest if you can. Let your mind wander through the possibilities we have explored. Let the words and concepts dissolve into dreams, where logic loosens and imagination flows more freely. Perhaps your sleeping mind will make connections that waking consciousness could not. Perhaps you will wake with insights you did not have before. Or perhaps you will simply sleep and wake refreshed, having processed the information in ways that do not require conscious recall. Either way, the sleep is valuable. The rest is necessary. The question will remain when you wake. The institutions that monitor space continue their work through night and day. Telescopes track known objects and search for new ones. Computers process data and flag anomalies. Scientists analyze observations and refine models. The machinery of astronomical research operates continuously, attended by those whose job is to watch the sky. They will see 3I Atlas emerge when geometry permits. We'll begin the detailed observations that should clarify what we are dealing with. We'll provide the data that allows more secure conclusions about the object's nature. That data will be shared according to protocols that have developed over decades of astronomical practice, published in journals, announced at conferences, posted on preprint servers, made available to scientific community, and eventually to interested public. The transparency is imperfect, but substantial. We will know what they find reasonably quickly after they find it. We'll be able to evaluate their interpretations against our own understanding. We'll participate in collective process of sense-making that follows surprising observation. This transparency matters more now than perhaps ever before. When the question at stake is whether we are being visited by artificial object from another star system, secrecy would be corrosive to trust. people would assume the worst, would imagine conspiracies and cover-ups, would fill information vacuum with speculation more alarming than reality likely is. Better to be open about uncertainty than to create false sense of hidden knowledge. Better to share data and let many minds work on interpretation than to restrict analysis to small group. Of course, national security considerations might complicate full transparency if object is indeed artificial and potentially threatening. Governments might reasonably want to assess capabilities and intent before revealing everything to public, might want to consider defensive measures or diplomatic approaches before broadcasting findings widely. That tension between openness and security cannot be fully resolved, but it can be managed through graduated disclosure that shares information while protecting legitimate security interests. Hopefully, that balancing act does not become necessary. Hopefully, 3I Atlas reveals itself to be natural object with unusual but explicable properties. Then we study it as interesting astronomical phenomenon without the complications that artificial origin would introduce, without the need for protocols we do not have, and institutions we have not built, without the pressure to respond to presence of intelligence from beyond Earth. But we must acknowledge that easier is not always better, that complications sometimes bring benefits that outweigh their challenges, that discovering we are not alone, however difficult that discovery might be to process, could be greatest gift our generation receives, could be the knowledge that transforms human future from isolated struggle on single planet to participation in larger cosmic community, could be the revelation that gives meaning and direction to our technological development and our expansion into space. So perhaps we should not hope for easy answer. Perhaps we should hope for true answer, whatever that turns out to be. Hope that data is clear enough to support confident conclusions. Hope that observations are sufficient to resolve uncertainty. Hope that nature cooperates with our desire to understand by providing evidence that points clearly in one direction or another. That is perhaps the best we can hope for. Not particular outcome, but clarity in whatever outcome occurs. October 28th passes with the weight of expectation. Tomorrow is perihelion. Tomorrow, the object reaches point of closest approach. Tomorrow, physics tests whatever 3I Atlas is made of under conditions of maximum stress and exposure. Tomorrow begins the slow process of answers emerging from the geometry of light and orbits. The last night before perihelion feels different somehow, though objectively it is just another rotation of Earth, just another passage of hours measured by atomic clocks that care nothing for human significance. But subjective experience matters too. The feeling that something important is about to occur. The awareness that uncertainty will begin to lift. The anticipation of questions moving toward resolution. In that anticipation, try to find some peace. Try to remember that whatever happens tomorrow occurs according to natural law. Physics does not care about our theories or hopes. Objects move and heat and respond to forces according to equations that were true before humans existed and will remain true after we are gone. Our observation does not change the physics, only reveals it. Our interpretation does not alter the object, only classifies it. We are witnesses, not participants, in the drama of 3I Atlas approaching the sun. And as witnesses, our role is to watch carefully and think clearly, to observe without projecting our desires onto what we see, to interpret without forcing observations into preferred narratives, to remain open to surprise while maintaining skepticism about extraordinary claims, to balance hope and caution, to hold multiple possibilities simultaneously until evidence indicates which corresponds to reality. This balance is perhaps the most important skill for navigating uncertainty. Not rushing to conclusion, not dismissing possibilities prematurely, not being so open-minded that our brains fall out, nor so skeptical that we cannot recognize genuine anomalies when they appear. Walking the line between credulity and dismissiveness. Acknowledging that we do not know while remaining committed to finding out through careful observation and rigorous analysis. Tomorrow, that process accelerates. Tomorrow, Atlas passes through perihelion, and whatever happens, happens. And then, slowly, we will begin to see the results, begin to measure the aftermath, begin to understand whether this visitor from beyond is ice or is something else, begin to answer the question that has occupied us through these weeks of approach and speculation. But tonight, this night before perihelion, we still live in the uncertainty, still exist in superposition where all possibilities remain open, still face the unknown without yet facing the known. This liminal space between question and answer has its own strange beauty, its own significance, because it is the space where wonder lives, where curiosity remains unconstrained by fact, where imagination can explore freely before reality constrains it. So breathe in this moment, this last night before some portion of the mystery resolves. Feel the question sitting in your awareness without demanding immediate answer. Let it be okay that you do not know yet. Let it be acceptable that knowing requires patience and process and time. Let yourself exist comfortably in the not knowing, understanding that it is temporary but real, that it will pass, but matters now. The darkness outside your window contains the object we have been discussing, hidden behind the sun, invisible to observation, approaching the point of maximum heating and stress, moving through space at 25 kilometers every second, following trajectory that brings it closer with each moment, experiencing conditions that will test whether it is bound ice or whether it is something that can withstand those conditions without fragmenting. We cannot see it now, cannot measure it, cannot know what state it is in or what processes occur within or around it. That ignorance is absolute and temporary. The geometry will shift. The object will emerge. And we will see what perihelion has made of this visitor from beyond our solar system. Until then, the waiting, the breathing, the acceptance that answers come when they come, that we cannot rush the universe into revealing its secrets faster than physics and geometry allow. That patience is not just virtue, but necessity when dealing with cosmic phenomena that move on timescales larger than human impatience can comfortably accommodate. The stars wheel overhead in their ancient dance. The same stars that guided sailors and inspired philosophers. The same stars that will shine long after this moment is forgotten by any who remember it. They care nothing for our questions about one small object moving through the vast darkness between them. They burn according to nuclear fusion. They orbit according to gravity. They exist in their own reality that includes us only incidentally. And yet, we care about that one small object. Care deeply about what it is and why it is here. Care because the answer tells us something about our place in the cosmos, about whether we are alone, about what existence means in a universe that might contain other minds besides our own. The question matters, even though the stars do not care. Matters because we are here to ask it. Because consciousness has emerged at least once in this universe, and wonders whether it has emerged elsewhere as well. That wondering is perhaps the most human thing we do. Looking up at night sky and asking what else is out there. Who else might be looking back? Whether the vast darkness contains only physics, or whether it also contains purpose and meaning and minds that think and question as we do. Whether we are alone in our wondering or part of larger community of wondering beings distributed across the light years. 3i Atlas cannot answer all those questions, regardless of what it is. But it can begin to answer them, can provide one data point about whether artificial objects visit star systems, can tell us whether intelligence has reached capability to send probes across interstellar distances, can give us first concrete evidence that we are not alone, or confirm that we have not yet encountered clear signs of others. Either answer changes things. Either answer tells us something important. Natural comet tells us that interstellar space contains rocky, icy bodies that sometimes pass through solar systems. Artificial probe tells us that intelligence exists beyond Earth and has achieved capacity to reach us. Both are valuable to know. Both advance our understanding. But one advances it much further than the other. One represents ordinary discovery. The other represents extraordinary discovery, with implications for everything we think we know about our cosmic status. And so we wait for October 29th. Wait for perihelion. Wait for the geometry to shift and the object to emerge. Wait for data to begin resolving uncertainty into something approaching knowledge. Wait with whatever patience we can summon. Wait while the universe proceeds at its own pace, indifferent to our desire for answers. The waiting is almost over. Tomorrow changes things. Tomorrow we enter new phase where observation becomes possible again. Tomorrow we begin to learn what 3i Atlas truly is. Tomorrow the mystery begins to dissolve, slowly, partially, into something we can measure and understand and respond to appropriately. But tonight, this night, we still live in the question, still face the unknown, still exist in that liminal space where possibilities remain open and answers remain deferred. And in that space, if you can, find some peace. Find some acceptance of uncertainty. Find some appreciation for the mystery itself, knowing that it will soon begin to resolve, but that this moment of pure not knowing has its own value and its own strange beauty. Sleep if you can. Dream if you will. Let your consciousness drift into other states where logic loosens and imagination flows freely. The object will reach perihelion whether you are awake or asleep. Will be tested by sun's heat and gravity, whether you witness it or not. Your rest does not impede the process. Your sleep does not prevent the revelation. And when you wake, we will be one day closer to understanding. One day closer to knowing whether we watched a comet or whether we witnessed something else. One day into the new phase where observation resumes and data begins to flow. One day further from the question and closer to whatever answer the universe provides. Until then, breathe. Rest. Let go of the need to know right now. Trust that the answer will come when it comes. Trust that the universe reveals its nature according to its own timeline. Trust that perihelion will pass and emergence will occur and understanding will advance. Trust the process even when you cannot see the outcome. The darkness is deep and the stars are distant and the object is hidden. But tomorrow brings change. Tomorrow brings light. Tomorrow begins the slow revelation of truth about this visitor from beyond. Tomorrow, we begin to learn whether we are alone or whether we are accompanied, whether we are watched or merely observed by indifferent physics, whether the universe contains other minds or whether consciousness is singular achievement that occurred only here on Earth. These are large questions, questions that deserve careful thought and patient observation, questions that we cannot rush, even though we might wish to, questions that will be answered not by wanting answers, but by watching carefully and measuring precisely and thinking clearly about what the data tells us. So as October 28th ends and October 29th begins, as perihelion approaches and then passes and then recedes, as the object begins its slow emergence back into observable space, we prepare ourselves mentally for whatever comes, for confirmation of natural origin, for evidence of artificial origin, for continued ambiguity that requires more observation and more analysis, for any of the possibilities that the universe might present. We prepare by remaining open, by maintaining balance between skepticism and wonder, by committing to follow evidence wherever it leads, by accepting that the answer might not be what we hoped for or expected, but will be true, regardless of our preferences, by remembering that the universe is under no obligation to make itself easily understood. That mystery is natural state of reality, and understanding is hard won through observation and thought. And with that preparation, with that commitment to clarity over comfort and truth over preference, we face the approaching perihelion with calm, with the awareness that something important occurs, but without panic or ungrounded excitement, with curiosity balanced by patience, with hope balanced by realism. The final hours before perihelion tick away. The object speeds sunward, following trajectory that cannot be altered by our observation or our wishes. Physics proceeds with absolute reliability. The equations that describe motion and heating and gravitational stress operate without exception. What will happen is already determined by the object's composition and structure and the environment it enters. We merely wait to observe the outcome. And in that waiting, in these final hours before answers begin to emerge, we can reflect on how remarkable it is to be alive at this moment, to be conscious during the week when an interstellar visitor passes through our solar system and challenges our understanding. To have developed the technology to detect and study such objects, to have reached the point where questions about artificial origin are not fantasy, but genuine scientific inquiry based on observed anomalies. Our ancestors looked at the same stars and wondered about them, wondered whether other worlds existed, whether other beings looked back, whether humanity was alone. But they could only wonder, could only speculate, could not observe or measure or test. We have moved beyond speculation to observation, beyond philosophy to science, beyond wondering in the dark to actually investigating with tools and methods that reveal truth about physical reality. That transition from speculation to investigation represents one of humanity's greatest achievements. The development of scientific method, the creation of instruments that extend our senses, the building of institutions that accumulate and refine knowledge across generations, the cultivation of intellectual virtues like curiosity and skepticism and openness to being wrong. All of these enable us to actually find out, rather than merely guess about questions that previous generations could only wonder about. And now that method, and those tools, and those institutions face a test case that might be the most significant they have ever faced. A question about whether an observed object is natural or artificial. A question about whether we are alone or visited. A question whose answer could transform human civilization if it goes one way rather than another. The weight of that potential transformation adds gravity to these hours of waiting, makes them feel important in ways that ordinary time does not. We are potentially living through a pivot point in human history, a before and after moment, the era when we were alone and the era when we knew we were not. Or, alternatively, the moment when we carefully investigated an unusual comet and learned it was only a comet, and life continued mostly as before with slightly better understanding of interstellar objects, but without fundamental revision of our cosmic status. Both outcomes are possible. Both remain in superposition until observation collapses the possibilities into single actuality, and we cannot know which until the data arrives. Cannot predict with certainty, can only wait and watch and remain committed to accepting whatever truth the universe reveals. October 29th has arrived. Perihelion occurs sometime during this day, depending on how precisely we calculate. The object reaches its closest point to the sun, feels maximum heating, experiences maximum gravitational stress, achieves maximum velocity. Everything that can happen happens during this window when the object is at closest approach. And we see none of it directly, see only the aftermath when the object emerges from behind the sun, see only the results of whatever processes occurred during perihelion. Must infer from post-perihelion state what happened during those invisible hours when observation was impossible. That inference will be based on careful measurement and comparison. Pre-perihelion state compared to post-perihelion state. Changes in brightness, in structure, in composition, in trajectory. Each difference tells us something about what the object experienced, about whether it fragmented or remained intact, about whether it brightened as expected or showed anomalous behavior, about whether its trajectory changed in ways that require thrust or remained consistent with gravity-only model. The observations will begin in early November, when the object separates sufficiently from Sun to be visible to Earth-based telescopes again. Multiple facilities will target it: amateur astronomers and professional observatories, space-based instruments, and ground-based stations. Everyone who can contribute will contribute. The data will accumulate rapidly once observation becomes possible. And then analysis begins. The hard work of interpreting what the measurements mean, of building models that explain observations, of testing hypotheses against data, of gradually converging on understanding through process that is messy and iterative and sometimes contentious, but ultimately self-correcting through peer review and replication. That process will take time, des états, minimum, possibly weeks or months, depending on how clear or ambiguous the observations are. We should not expect instant conclusions, should not assume that first observations will definitively resolve all questions, should prepare for a period of continued uncertainty while analysis proceeds and different groups reach different interpretations that must be reconciled or adjudicated through additional observation. But the process will move forward, will advance our understanding, even if it does not immediately produce consensus, will give us more information than we have now, will narrow the range of possibilities, even if it does not immediately select single answer. Progress will be incremental, but real. And eventually, sooner or later, we will reach conclusions that command broad agreement within scientific community. Those conclusions will then be communicated to public, will be translated from technical language to terms that non-specialists can understand, will be contextualized and explained, will be subject to interpretation by different voices with different agendas and different levels of expertise. The signal will get mixed with noise as information spreads through media and social networks. But the signal will be there for those willing to look for it, for those committed to finding reliable sources and distinguishing careful analysis from speculation. So we prepare not just for perihelion itself, but for the aftermath, for the weeks of observation and analysis that follow, for the debates and discussions and gradual convergence toward understanding, for the possibility that answers come more slowly than we might wish, for the patience required to let the process work as it should, rather than demanding premature conclusions. And through it all, we maintain our balance, our commitment to following evidence, our openness to surprise, our willingness to be wrong about preliminary conclusions if data indicates we should revise them, our determination to care more about truth than about being right, our acceptance that understanding the universe requires humility about our own limitations and respect for the complexity of phenomena we study. These virtues matter now more than usual because the stakes are unusually high, because the question touches on deep human concerns about meaning and purpose and our place in cosmos, because the answer, whatever it is, will affect how we think about ourselves and our future. because we need to get this right, or at least to approach it with appropriate care and rigor. Perihelion passes. The moment occurs. The object reaches its closest point to the sun. Whatever happens, happens according to laws of physics that care nothing for our theories or hopes. The outcome is determined by what the object actually is, not by what we think or wish it might be. Reality proceeds with absolute indifference to human preferences. And now, the waiting shifts from anticipation to patience, from looking forward to perihelion to looking forward to emergence, from wondering what will happen to wondering what did happen, from uncertainty about future to uncertainty about recent past. The nature of a not knowing changes, but the fact of not knowing persists. We still do not see, still do not know, still must wait for geometry to permit observation. But we are closer now, have passed through the moment of greatest invisibility, have begun the phase where the object starts to separate from sun in our sky, still not visible yet, still too close to solar glare, but moving in direction that leads eventually to observable position, moving toward revelation, whether that revelation confirms our theories or surprises us with something we did not predict. The universe is patient, has been revealing itself slowly across centuries of scientific investigation, has given up its secrets gradually through the efforts of countless observers and thinkers who looked carefully and thought rigorously and communicated their findings, has taught us that understanding comes from cumulative effort across many minds and many generations, has shown us that knowledge is collaborative achievement rather than individual insight. And now we are part of that collaborative effort, part of the distributed intelligence trying to understand what moves through our solar system, part of the human project of making sense of cosmos we inhabit. Small part, perhaps. Individual contribution might be minimal, but part nonetheless. Participant rather than passive observer. Engaged rather than indifferent. That engagement has value regardless of outcome. The process of paying attention, of thinking carefully about what might be true, of following observation and analysis as it unfolds, of participating in collective sense-making around questions that matter. All of this enriches understanding, even if it does not lead to dramatic discoveries. All of this connects us to larger human endeavor of investigating reality and expanding knowledge. So as perihelion passes, and we enter the days of waiting for emergence, we can take satisfaction in the engagement itself, in the attention we have paid, in the care we have brought to thinking about these questions, in the balance we have maintained between openness and skepticism, in the patience we have cultivated while waiting for observation to become possible. These are valuable practices, regardless of what 3i Atlas turns out to be. And soon, sooner than seems possible, given how long the waiting has felt, we will begin to know. We'll begin to see the object again. We'll begin to measure its state post-perihelion. We'll begin to interpret what those measurements mean. We'll begin to answer the questions that have occupied us through these weeks of approach and speculation. The uncertainty will begin to lift. The mystery will begin to resolve. Understanding will advance. But not yet. Not quite yet. For these last days before emergence, the mystery persists. The Goethe question remains unanswered. The possibilities remain in superposition, and we can rest in that uncertainty, can accept that knowing comes later, can release the tension of needing to know now, can trust that the process will unfold as it should, and that answers will arrive when geometry permits, and that patience is not obstacle, but prerequisite to understanding. Sleep comes easier when we stop fighting the not knowing, when we accept it as temporary, but real, when we allow ourselves to not have answers while remaining committed to finding them when possible. The universe does not require our constant vigilance. The stars will shine whether we watch them or not. The object will emerge whether we stay awake or sleep. Our rest does not impede reality from revealing itself according to its own timeline. So, rest. Let go of the questions for now. Let them drift into the background of awareness rather than demanding constant attention. Trust that when observation becomes possible, those who watch will watch carefully. That when data arrives, those who analyze will analyze rigorously. That when conclusions emerge, those who communicate will communicate clearly. Trust the distributed system of science and society to function as it should. And when you wake, we will be closer to understanding. Closer to seeing 3I Atlas emerge from behind the sun. Closer to measuring what perihelion has done to or for this visitor from beyond our solar system. Closer to knowing whether we watched a comet or whether we witnessed something else. Closer to answering questions that matter not just for astronomy, but for how we understand our place in cosmos. The stars above remain constant in their patterns, even as everything beneath them changes. They shone before humans existed. Will shine after we are gone. Their light traveled for years or centuries or millennia to reach your eyes. Some of the stars you see tonight have died already, their light still traveling, while the star itself has exploded or cooled. Time works differently at cosmic scales. Light from past arrives in present. Objects separated by vast distances appear adjacent in sky. The universe is strange and beautiful, and far more complex than immediate perception suggests. And somewhere in that strange, beautiful universe, an object we call 3I Atlas follows its trajectory, moves according to mathematics that describe motion through space-time, exists as physical thing with mass and momentum, and whatever internal structure or lack thereof defines its nature. Real object, real trajectory, real mystery that will resolve into real knowledge through real observation. That grounding in reality matters. Amidst speculation and uncertainty and possibility, we must remember that something real moves through space above us, something we can observe and measure and understand through the methods we have developed for investigating physical reality, something that exists independent of our theories or wishes, something that will teach us what it is through its behavior if we watch carefully and think clearly. So we watch, we think, we wait, and the universe proceeds with its revelations according to its own timeline. The object emerges when geometry permits. Data arrives when light travels from object to detectors. Understanding comes when analysis transforms data into interpretation. All of this takes time. More time than human impatience prefers, but less time than cosmic processes usually require. And in that time, in these last days before emergence, we can find some peace with not knowing, can accept uncertainty as natural state of being at the boundary between question and answer, can appreciate the mystery while it lasts, knowing it will dissolve soon into something more solid and knowable, and perhaps less wondrous, but more useful for guiding our response. The night deepens. The stars wheel overhead. The object moves through space on its predetermined path, and we rest here in the darkness, waiting for the morning, waiting for the light, waiting for the slow revelation of truth about this visitor from beyond our solar system, and what its arrival means for our understanding of the cosmos and our place within it. And in that waiting, in that rest, in that patient acceptance of mystery and uncertainty, perhaps we find something valuable, some reminder of our human limitations, some appreciation for the vastness of what we do not know, some humility about our position as small, conscious beings trying to understand a universe that vastly exceeds our capacity for comprehension, some gratitude for the moments when mystery resolves into understanding through our collective efforts at observation and analysis. 3i Atlas will emerge. We will observe it. We will learn what we can learn. The mystery will shift, if not fully resolve. And we will continue, as we always have, looking up at the night sky, asking questions about what we see, wondering about our place and purpose in this strange and beautiful cosmos. And perhaps that wondering is enough. Perhaps the question matters as much as the answer. Perhaps the search for understanding is its own reward, regardless of what we find. Perhaps we are most human when we look up at something we do not understand and commit ourselves to finding out through observation and thought and collaboration. 3i Atlas moves through space. We move through time. The geometry shifts slowly, but inevitably. And soon, very soon, we will see what there is to see. We'll know what there is to know. We'll understand what we can understand. Until then, the waiting, the breathing, the rest, the quiet acceptance of mystery, and the patient trust that answers come when they come. And perhaps that is enough. Perhaps the waiting itself has meaning. Perhaps the mystery is part of the message. Perhaps we are not waiting for a signal at all. Perhaps the signal is the waiting.